Hello and welcome to Unit 4, Part 5. My name is Mr. Bell and today we're going to talk about rational versus irrational numbers. Let's begin with rational numbers. The definition of a rational number is any number that can be written as a fraction that doesn't have zero in the denominator. Now, some examples of this are like the number 3/4. The number 5 is also a rational number because 5 can be written as 5/1. Most of the numbers we use are rational numbers. Rational numbers can also be negative. Now sometimes that definition of a rational number is confusing, and to me it's a little easier to first evaluate, is it an irrational number, and if it doesn't meet the criteria of an irrational number, then it must be rational. What do I mean by that? An irrational number, when it's simplified in a calculator, will be a decimal number that does not follow any kind of pattern and continues on forever, which means we can't simplify this into a fraction like a rational number. You won't always see it in this form though, this large decimal number that doesn't really show any kind of pattern. Sometimes you'll see it written like this. It'll be something like 2 times pi. Well, if we evaluated what 2 times pi actually equals as a decimal number, you get the result of 6.283185307, continues on. So don't get caught up in just looking at it and say, oh, well, 2 pi looks like a nice clean number, it's rational. Use your calculator or whatever device you have, convert it to decimal form, and in my mind, this is a really easy situation to recognize as an irrational number. You may have heard your parents or at some point say, gosh, you're acting irrational. It means you're really not making a lot of sense. Okay, there's really no pattern to what you're doing. You're being very irrational. If it does not simplify to be a decimal like this, then it's going to result in a rational number. Now let's look at some examples on the next slide. This slide asks us to label the following numbers as rational or irrational. Good practice for me is to go ahead and convert all of your numbers into decimal form so we can make that distinction we talked about on the previous slide. We've already talked about what 2 pi is equal to. 2 pi is equal to 6.283185307, but we don't really even need all that. We can easily recognize this as an example of an irrational number. Okay, I'm just going to put IR for irrational. 6.7, if you notice, it is a decimal number, but it's terminating. It has a pattern. It's not an irrational situation like the previous example where there's a bunch of random decimal numbers. 6.7 is actually a rational number, which I'll just use a capital R for rational. 3/5, well, when you convert 3/5 in your calculator to a decimal number, you get 0.6. Notice that 0.6 is still a decimal number, but it's not that crazy irrational pattern, so this is also a rational number. The square root of 16, now you may see the square root symbol and think, oh, that's got to be irrational. Well, it depends. When you type in your calculator the square root of 16, it gives you a value of 4. 4 can be written as a fraction, 4/1. It also doesn't meet the criteria for irrational number because there is no random pattern of decimal numbers, so this is also a rational number. On this slide, it says to analyze the following operations on rational and irrational numbers. Determine a pattern if one exists with the operations and the results. These three are almost worth putting back to memory, to memorizing these. What they're asking is when you take different situations and different operations, what is the result? Is it always the same or can it be one of two things? These are 3 pretty common ones that you're given. One thing that you can do to try to help you is come up with an example of a rational number, add it to another rational number, and see what the result is. In this case, a rational number like 5 plus a rational number like 6 gives you a result of 11. Every time you add 2 rational numbers, you will always get a rational number answer. Okay? Rational times irrational. So this would be something like taking, we'll use our example from the previous slide, 2, and then multiplying that by an irrational number, which pi is an irrational number. If you simplify pi in the calculator, it doesn't just round to 3.14. It's a an irrational number with infinite many random decimal numbers. So when you multiply a rational number times an irrational number, you will always get an irrational answer. You can always check this with numbers if you're not sure. Now the last one in my mind is very, very tricky. It says an irrational times an irrational. Well, this one can actually be either one of the above. It can be either rational or irrational. It just depends on the scenario. Let's take an irrational number like the square root of 2 and multiply it by the square root of 5. Well, that would give us a result of the square root of 10, which simplifies to 3.162277766. It's going to be a bunch of crazy decimal numbers, so this is an example of an irrational answer. We have to look at another set of numbers though. Let's take a look at the same irrational root 2 times root 2, which those are both examples of irrational numbers. You get the result of the square root of 4. And if you take the square root of 4 or you simplify it in your calculator, you get an answer of 2, or negative 2, which is an example of a rational number. Notice how the same situation, irrational times irrational, in both cases, one resulted in an irrational answer, one resulted in a rational answer. So this situation, it can be either rational or irrational. This last example reads, which expressions represent rational numbers? Select all that apply. This is a very common standardized test question that you might see on a state test or in the ACT or SAT. And let me tell you how I would work through this. Just looking at the answer choices, I am not capable of determining which of those are rational versus irrational. But I know that I can convert each answer choice into a decimal number, and it will make this problem so much easier. So let's do that real quick. Now that I've converted all the answer choices to decimal numbers, I think it becomes a lot easier to look and see. I can see real quick that answer choice A is 320, which we learned is a rational number. Answer choice B is a irrational pattern there with a bunch of random decimal numbers, so we'll label that as irrational. Answer choice C is 20, which is a rational number. Answer choice D is 31.627417. This is an example of an irrational number. Also, answer choice E is an irrational number. And the last one, answer choice F, 0.9, even though it's a decimal number, it does not meet the same criteria or the same pattern as irrational numbers. So this would be considered a rational number. Now be sure you go back and read the question. Which expressions represent rational numbers? So you're only going to select A, C, and F are the examples of rational numbers. All right, thanks for watching. Hope this helps.